Hi, I'm Janet Bowers. Welcome to the Liberal Studies Mathematics Review. I'm going to be going over module number 1, fractions. So one of the questions that I think a lot of people ask is, why are fractions even useful? And I think the question might even be stated, why are fractions useful to understand conceptually? I'll give you a second to think about that. For example, why don't we just memorize? And I mean, I think if you ask a lot of people, hey, I know how to manipulate fractions and I know when to get a common denominator. Well, I think some people probably would say that they do, but at the same time, we have seen so many students who say, now, do I get a common denominator when I'm multiplying or when I'm adding? And as a mathematics teacher in elementary school or even middle school, it's really important that you understand when you do which, and sometimes you add fractions and you don't get a common denominator. So the idea of how the algorithms come about, that's conceptual. So if they want to memorize an algorithm once they understand it, that's great. The problem is just thinking that I could never understand this, so I'm just going to memorize it. So a second question, a second part of this question is, why are they useful to me as a liberal studies student? And so at one level, we can imagine sort of a stair stepper kind of pattern that's just going to keep going up and up and up. But at one level, we actually can start off with fractions. And those are the fractions that you learned in Math 210 or its equivalent at a community college. And at that level, you're really thinking about parts of a whole, right? So you're looking at a part to whole comparison. Sometimes you looked at discretes, like the number of jelly beans in a jar, or sometimes you looked at continuous. For example, if you want to think about temperature, temperature is going up incrementally. Maybe you want to look at what fraction of 100 degrees it is outside, for example. Another layer is ratios. At a second level, we can think about ratios, and ratios you see in 210 or the equivalent, but also in 211. It's really important for comparing one part to another part. And yeah, it's easy to talk about this sort of stuff without an example, but then you put the examples in and they seem a lot harder. But if we can think about it from this basis, then the ideas build on themselves. So at a third level, we have percents, and percents, are used in 210, 211, and definitely in 312, because in Math 312, that's probability. And probability is usually described in terms of a number from 0 to 1 or a percent that something is going to happen. And finally, at higher levels, we have the idea of intensive quantities. And intensive quantities are used all the time. If I put a Q there, they're certainly introduced in 313, and then we use them forever after that. So an intensive quantity is not saying I have a number on the top and a number on the bottom, but what you're really interested in is the number that occurs when you divide those two. So it's looking at one quantity. So for example, one quick example is speed, right? Miles per hour. And so I could go 120 miles per 2 hours. But if let's say, you're driving to LA and your friend said, hey, how fast you go? I said, oh, I went 120 miles in 2 hours. Usually you say, nope, I went about 60 miles an hour. And that gives you kind of a one number to compare. And oh, I went 75 miles an hour. So then you have even that would, instead of having 4 numbers to compare, well, I went 120 in 2, or I went 150 in 2, you can say, nope, I went 75 versus 60. So the general idea here is that we're building on ideas. And if this part falters, if you don't have a deep understanding from a conceptual point of view, then the rest gets really hard. And so that's why we're going to be focusing on these two topics in this module. All right, so let's get going.